Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 4 to this YouTube action RPG series in Godot 4. By the end of this episode, you will have created a dirt path like this using Godot's tiles and Autotile system, and these dirt cliffs. We'll have created this grass that we can destroy with our sword. Creates a nice little effect when it gets destroyed. Some of the principles and concepts that we'll be discussing here are setting up collision shapes on Autotiles, Godot's terrain system for the tiles, and we'll also be learning about signals and how to instantiate scenes dynamically while the game is running. So I'm excited to get started. Let's jump right into it. Our bushes and trees do a pretty good job of breaking up the world here, but this grass background layer still tiles, and you can kind of notice the repeating of that tile. So what we'll do to fix this is to add our dirt path tiles. To add tiles to our world, we'll need to use Godot's tile map layer node. Click on the world, click the plus button, and search tile map. Now tile map is depreciated. This is what Godot used to use. It had layers built into it, which was maybe a little too much responsibility, so they decided to make a tile map layer node and swap those so the layers were handled outside of the actual node and in the scene tree over here. So you can have multiple tile map layers. Now we're just going to select this tile map layer here, and we'll call this dirt tile map layer. Now a tile map is the thing that you use to draw tiles, and it remembers where you've drawn the tiles and kind of creates a map. That's why the name map is in there. But it has to have data, tile data, to pull from. And so we'll come over here to the right, and we have the tile set. The tile set is where we manipulate the tile data that the map uses to create a map. Let's create a new tile set resource. And then down here, when we have this tab opened up, for the tile map layer, we have a tile set tab and a tile map tab. Now, it could be easy to confuse those, but again, think about it in terms of this is the data for the tiles that the tile map uses to create the map. So we'll come to tile set, and then we need to create tile sources. So we'll do this little plus here and do atlas, come into world, and then we have the dirt tile set right here. And Godot is automatically going to create some tiles for us. We're going to press yes. And it created a tile basically everywhere. We can middle click to pan and scroll to zoom. Created a tile basically everywhere that it found some pixels in this tile set here. Now we could go to our tile map and manually add some of these tiles to the world, but it would be very difficult because we'd have to manually place each tile to try and get the right one we want for that location. And that's a huge pain. So we want to use Godot's Autotiling, which is now located under their terrain feature. So come back to the tile set where we set up the data, and then go to paint. And if we select a property in the editor that we want to paint onto these tiles, and keep in mind this is painting onto this tile data, it's not actually painting into our world here. We're just telling Godot what type of information these tiles need to have in them. And in this case, we're painting the Autotile information or the terrain data. We're going to click down here on select a property, and we're going to select terrains. Now there aren't any terrains that we have access to, and so we can't paint anything. So we want to come over here to tile set, click on the resource, and it will open up this. And then once we've clicked on that and it's opened up this, we'll have terrain sets, and we can add a new terrain set element. So we'll add a new one, and then we'll click terrains. So now make sure you have terrains selected here, because we can add a new terrain set, but really we want to add a new terrain, and these buttons are very close to each other, so you want to make sure you're adding a new terrain. And once we get this terrain, that color looks fine as a way to represent this terrain, since it is dirt. And we can come back over here. We can select terrain set 0, and we can select all the tiles that we want to use this terrain set. because you can imagine that potentially your atlas might have other types of terrains in it as well. We only have this one, so we're just going to select all those tiles. Now that we've picked which tiles are going to use this terrain data, we need to give it the rules for when it should place specific tiles. And you can see I have this little teeny square inside of the tiles now, and that's how we're going to be able to apply the rules. So let's start with this top left tile right here. If we wanted our Autotile to place this tile, when would we want it to place it? Well, we'd want it to place it, and I forgot to select the terrain. Whoops. We'd want it to place it when there was a tile below it, and to the right of it, and down in that bottom right corner. But we don't want it to place this tile if there's anything over here, so we want to leave that blank, or here, so we want to leave that blank. So if you imagine this configuration, right? This middle tile represents the tile we're placing, and then these other tiles represent the tiles surrounding it. So if the right is filled and below it is filled and this bottom right corner is filled, then we want it to automatically place this tile. Now if we look at something else like this middle tile, this tile we want it to be placed when all of the tiles around it are filled. And that makes sense because it's just a completely filled space here. Now if we look at this one right here, when do we want to place this tile? We want to place it when none of the tiles around it are placed. This right here is a single isolated tile. So that's what the rule looks like for it. Now I kind of have done this enough that I don't have to think about the rules anymore that way, but I wanted to show you how the rules work, so if you need to, you can logic through it. So I'm just going to start drawing because I know what it's going to look like with this particular configuration of tiles, and you can kind of copy what I'm doing as well. And we'll see how well I can remember, because over here it's a little harder to tell where they go because the only thing is these little darker bits here in the corner because of the tile set that I'm using. But this is how it goes. This is a plus here, if I remember. And then, let's see, this one right here looks something like this, if I remember. And this middle part is filled. And I don't remember if anything else is. I don't think it is. I think that's what that part looks like. And then we get some tiles all the way along here. And here, 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 and here. And then some of these are filled in, but it is kind of hard to see sometimes. Yeah, that looks right. Like that. Down here, it's not supposed to have one there. I accidentally drew that. You have to be careful because if you put one in the wrong spot, it's going to mess up your auto tiling. And then this is basically these two kind of configurations like that. Okay, so you can pause your video and make sure that you copy this over. It has to be exact because if any of these are even the slightest bit different, your auto tile won't work. Now that we've set up the rules inside of our tile set around the terrain, we can go to our tile map and we can start painting in the world. And we'll click terrains here and select terrain 0. And then it's automatically set up to where we can just start painting in these tiles and it will automatically select the correct tiles for the place that we're doing it. Now you can right click to delete tiles and left click to create them. If you hold shift and control at the same time, you can do bigger clumps like this, delete and create bigger clumps. I'm going to kind of draw these tiles around these trees and bushes to create like maybe a little meeting point here where there's some diverging paths. Now, our tile map layer here is currently set up with autotiling, or not autotiling, Y sorting. And the Y sorting is because the world has everything under it Y sorted. Now we don't want that for our tile map layer. Let's bring it up and drag it up under our parallax layer. Now, if you accidentally put it on the parallax layer, you're going to get infinite tiling of that, which we don't want. So make sure that you drag it up above the player, but not on the parallax layer. And then we could create a new node here, and it can just be a node 2D. And we can call this ground layer. And I'm going to move both our parallax and our tile map layer to this ground layer. And now on its ordering, we won't turn on Y sort. And then theoretically, we can still go behind this ground layer now. And so we want to make sure that we can never go behind this ground layer. So if we go into the ordering, we can turn our Z index into something very, very small, like -1000. And then, I mean, technically, I think you might be able to trigger it if you ran off into the distance for long enough. Not sure how far you'd have to go, but if you need to make it even smaller to make sure that your character couldn't ever go behind it in the world, you could do that. Although I don't see, I mean, 1000 is forever. I don't know that I can ever get to that point. In fact, do we even have to do that? What if we just did -1? Does that guarantee that since it's not Y sorted, it will never display? Huh, maybe it does. Since it's drawing automatically under the world now. And I wonder if we could just even do display behind parent, show behind parent. This is for science. I'm testing some stuff here. Nope, show behind parent doesn't work. But adjusting the Z index just to -1 works fine. I'm going to do -10 just to give a little bit of extra cushion there. But now we have this ground layer that doesn't have any sort of Z or Y sorting on it. And if we put anything on here, it will just kind of be on the ground layer. But the order in which we draw these nodes matters. Like we want our dirt tile map layer to be above the parallax grass layer right here. Now that we set up our dirt path autotile, we're going to set up our cliff autotile. We'll come over to the ground layer, add a new node, search the tile map layer node, add that. Now the first thing you'll notice is that our dirt path looks weird now. It looks way dark. That's because when you're selecting a tile map layer, Godot automatically darkens all the other tile map layers in the scene, which can be visually jarring. So I just want to point that out. It didn't actually change the color. If we click on our world again, you can see that this is the actual color, but it is just darkening that out. Now we're going to set up the tile map layer here, and you can try and do this on your own if you want to challenge yourself, but there are going to be a few small differences because the cliff tile set has tiles that are 32 by 32 rather than 16 by 16. And so that's going to affect some of the setup that you'll have to do. But it won't actually affect like the auto tiling terrain stuff. It's just the initial setup. So if you want to challenge yourself to do it on your own, I think that's a good challenge and it would be good for you to try it. But I'm also going to walk you through it as a review. So let's name this cliff tile map layer, and we'll create a new tile set, and we'll add, we can come into this tile set and we can see the tile size. It's default set to 1616. Let's set this to 32 by 32. And then we'll add a new atlas and we'll do the cliff tile set. Godot wants to try and automatically add it, but I don't think this is going to work. We'll press yes just to see, but I don't think it's going to work. Oh, it did work. It missed this middle tile though. The reason it missed it is because technically there is nothing in that tile, so Godot decided, no, I'm not actually going to add this in. But let's click on that and just add that in so that we do have all those same tiles. So that's the difference, setting the tile size over here before we have it do it. Sometimes when it automatically creates the tiles, it doesn't work very well and you have to manually pick which tiles you want and which ones you don't want. So you can do that by left clicking and right clicking to delete. Save. Now we want to set up our terrain. So come over to terrain sets, add element, then click terrains and add element again. And sure, the color doesn't matter too much here because these are separate tile maps. We're not mixing terrains because these ones can just overlap with each other. And once we've done that, we can come to paint. Again, this is in the tile set tab, not tile map. Select the property we want to paint. We want to paint terrains. We want to select terrain set 0 and terrain 0. Then we want to select all of these tiles. These will all have terrain rules on them. Make sure I get them. There we go. And then we're going to set up the rules inside of here. And it's just going to look exactly how it looked before when we did it with the other ones. So if you remember the layout, it gets a little tricky down here because it does go down into the cliff just a bit. That's kind of hard to see. I might change the color. I want to make it easier to see. I'm going to make it more of an orange because I want you to be able to see it well. It was not too bad seeing it on the other tile set, but on here it was a little difficult. Okay. Just set these all up. Remember, it's pretty much the same as how it was set up before, the exact same pattern. But this is where it gets a little tricky because I'm trying to remember how this part goes. I think it goes like this, maybe like this. I think all of these are colored in here. And then we get kind of these edge ones coming out like this, if I remember. And then these two top ones right here look something like this and this. We'll find out real fast if I set that up right. And you can pause your video, make sure that yours looks exactly like mine, because if it doesn't, you're going to run into issues with the auto tiling. Okay, I'm going to save. I'm going to come back to our cliff map layer and select terrains and select this terrain. Now again, it's much bigger, as you can see, so you have to be a little careful. But we should be able to, and yes, there are issues in how I set it up. We can tell already that I set it up incorrectly. So let's go back to our tile set and take a look at what we did wrong. Okay, I figured out what I did wrong. It's a really easy mistake to make with these tiles, but you can see that I only came down 2 squares here. And this should come down more. Why? Because this corner one should actually be drawn when this is filled, when it's top right, and right tiles are all there. That's when we should place this corner tile. And it's confusing because you want to avoid these pixels down here that have actual cliff on them, but it's not about where it is exactly, it's about where it's supposed to be. Like down here you can see I go over the top of them correctly, but I didn't do it over here. So that was the issue. We'll save that. It's really easy to miss stuff like that sometimes and have your tile set not work, your auto tile not work. Just happens. So now that we have that, this should be set up better, and we can draw this cliff kind of edge around our player and kind of create some walls around the space like this. Now these walls are not currently interactable. If we run the game, our character can just walk right through them and there's no real depth to them. But what we can do is add a collision shape to our tile set. So come back to the Tileset tab, and over here, in the same way that we set up terrain sets, we can go to physics layers, add a new layer. We'll just leave it on this first layer right here, the default, and then we can come back to paint, and instead of selecting terrains, we can select physics layer, and now we have this collision shape that we can paint on all these layers. And I'm just going to fill in everything because our player character is not going to be able to get up on top of these cliffs. They're just to add some visual for the collisions in the game. I'm not going to cover like trying to handle fake depth in a 2D game and all of that stuff. That's way outside the scope of this series. So we're just going to add a collision shape to all of these. We can just click and drag. This is much easier than it used to be back in Godot 3. Just paint that right on there. And now when we run the game, our player character now collides with these walls. Now there is a little bit of some depth stuff, and you could turn on Y-sort for the walls if we come into them. And in fact, do they go over? I want to check this. Do they go over our dirt or under the dirt? Okay, so they are drawn on top of the dirt. So they're ordered here correctly. But we could, if we wanted to, we could pull them out of the ground layer and turn on Y-sort. We'll put them here by the player, out of our ground layer, and then turn on Y-sort under ordering. Turn on Y-sort. Did I get that right? Yes, I did. And make sure, I think there's some extra properties around how Y-sorting is handled. The offset axis, there's something in the tile map layer that affects Y-sorting, but we'll see if just this itself works pretty well. That does. That shows the cliff just that little bit above the player, so now the shadow doesn't go up on the cliff wall. You can see there is a little bit of sorting in that right there, the cape. But it works down here. And because of how it's set up, I actually am not sure I even want Y-sorting on. It just doesn't, because of the cape going up through it, I'm not sure we want it. Here are the extra properties though, because I think it's important to talk about these even if we don't use Y-sorting. If you come into rendering here, you can see we have a Y-sort origin, and you can alter this. So we could make this something like 32, which would push it down to the bottom of the tile. Since our tiles are 32 by 32, that would push the Y-sort origin down. And I'm just curious what that's actually going to look like. See, now we're so far down under the tile that our player is always drawn underneath like this. But if we set this to something like 16, for example, that would be in the middle of the tile itself. I think we would get, yeah, we're getting better sorting down there. We're still struggling with the cape kind of coming through some of this, although it's not nearly as bad. That's pretty close. So if my dirt Autotile actually had its own grass on top and was filled in, rather than being transparent and pretending like there's grass there, this sorting would actually look really good the way we have it set up. We could even try slightly more here, like 24, just to see, whoops, 24, and experiment with how this looks. But these are the assets I have, so I have to work within them and try and get it to look as good as I can with these assets. You can see now, player that's just a little too much, I think, because we can kind of go under that corner. And ultimately, I feel like the best look is just allowing that shadow to kind of go up on top and turning off Y sort completely, because we'll put it back into our ground layer here. Reorder it like this. Because the other visuals look the weirdest in my opinion. I'd rather have the shadow show just a little bit on top of that edge, but not have the cape kind of show there, but not have the other issues around how that looks. We're doing the best we can with these assets, but if you have your own assets, I think it's good that I covered how Y sorting works on Tilesets, because we actually got a pretty good look there if our cliff assets had been set up better than what they are. It would have been the correct Y sorting for the situation. We're just going to leave it like this. Now that we've got up that cliff tile set, we're ready for the next part. Now we've already talked a little bit about the difference between the tile map, where you draw the tiles in your world, and the tile set, where you set up all the properties on those tiles. But I also want to really quickly cover here that you can actually save these tile sets as their own resources and then reuse them on multiple tile map layers. So if one of the benefits of separating the tile set from the tile map is that your tile set and all of the data around those tiles isn't completely tied to a tile map. And so if you have multiple levels and you want to reuse your same tile set resource, you can come over here, click on this and go to Save As, and we can save this cliff tile set inside of World and just call it Cliff Tile Set and do Save as a TRES. And now it will be named that over here, and if we come, we can actually select it down here, and we can see the properties on that cliff tile set, and that resource can now be shared. If we were to create a whole new cliff, a whole new tile map layer right here, and just drag our cliff tile set over to it, now all of a sudden we have all of those same properties on this one, and that all of this, the same tile set that we set up can now be used on a different tile map. And so that's one of the reasons for the separation and the usefulness there. And I wanted to bring that up because if you were to build more levels, you might want to create more tile map layers, and you wouldn't want to have to reset up your tile set every single time you did that. But if you save it like this, you don't have to. And I'm going to save the dirt tile set as well. So do Save As and call this dirt tile set. However, keep in mind that again, these are shared. These resources are shared, which means if you have a tile set being used on multiple different tile maps, and then you make a change to that tile set, that change will propagate to all of the different tile maps. And so it won't just be changed on the one that you're currently working on, it will change on all of them. So keep that in mind. Just remember that resources are by default shared across Godot, and there are ways around that. We're not going to go into that for now, but it will propagate those changes to all tile maps that use that tile set. One of you in the comments pointed out a bug in the current version of the game that I wanted to address, and I appreciate you bringing that up so that we can fix it in this series in an actual video. It's very useful to have that back and forth dialogue with commenters. The problem is only apparent when we're running the game with a controller, because we're able to run much slower with the controller and control the speed. When we actually go to do a roll, if we roll, we're actually not getting faster roll speeds. And that's probably not the behavior we want. And so let's go into our player here. And all we have to do is in the roll state, we have to normalize this last input vector. So just do dot normalized right here. which, as we discussed before, will clamp it at 1. So a controller allows us, that analog stick allows us to get values between 0 and 1, like 0.5 or whatever. But if we set it to be normalized, then it's going to make sure that it's 1, no matter which direction it's pointing in. And that will allow us to now roll at full speed, even if we're only walking at a slower speed. Now that we've got our tile sets added to the game, we're going to add some grass that the player will be able to attack with their sword. We'll start by creating a new scene, and we can just make this scene a node 2D for now. We'll call this grass. We'll add a sprite to it. This brings up an interesting story, actually. When I very first started using Godot, I often would use sprites as the root node. But the problem with that is if you ever want to adjust the position of the sprite, that you'd have to adjust the position of the entire node. But if you start off with a node 2D and add the sprite as a child, then you can move the sprite but keep the original position of the node, which is useful for, if you imagine like jumping in a 2D isometric or 2D top-down like game. You could have the sprite move up but keep the location the same and have the shadow be in the same spot as well. So I generally recommend setting things up like this. Let's find our grass sprite and drag it over here. I'm going to put an offset on this because I want it to follow a 16 by 16 square so that when we're placing it in the room, it's going to line up a little bit more. Well, actually, let's just leave it like this for now. Maybe we'll change it, maybe we won't. We'll save it as grass, put it in here, come back to our world, and let's see if we can place it in here in a few different places. Yeah, that looks good. We can put it in that location like that. And oops, duplicate a few of these around. I'm just hitting Control D. And this will allow us to place some grass in a few different locations. And we're eventually going to have our player able to attack this. And there we go. Do something like that for now. That should be good. And save and run the game. Should Y sort, so that looks pretty good to have it Y sort as well. The problem we have now is if we attack the grass with our sword, oops, that was roll, nothing happens, right? We're not able to attack it. So how are we going to be able to detect overlap between the sword and the grass? There's a node that we can use specifically for this. Come back to our grass. And if you add a new node, there's something called an Area2D. Now, areas are used for detecting overlap. So unlike our character body, which handles collisions where you have like a collision where they meet, right? There's no overlap. The character shouldn't overlap with a wall. It should collide with that wall and move up to it and meet it. With Area2Ds, we can use it to detect if there's overlap between two things. We'll add an Area2D to our grass, and we'll add a new collision shape because it also uses a collision shape node. And we'll just do a little, we could do a little rectangle shape, just like this. And now we have a collision shape hooked up to this Area2D. Now we're going to attach a script to our grass, and that's because we need to be able to get information from this Area2D. Let's attach a script, just have it be called grass. We'll create that, and we can save. And this is where we can detect overlap. Now in Godot has a feature called signals. Signals are kind of like a notification that goes out and lets anyone subscribed to that notification, hint, hint, you want to subscribe to the channel? No. Anyone subscribed to that notification to be alerted to it, to be notified when that happens. So if we click on our Area2D and we go to Node over here, we can see the signals that are available to this specific node. And you can see there are a bunch of different signals here, but the ones we're concerned with are the ones under Area2D right here. And we can see we have one here called area entered. So whenever an area enters this area, it will emit out this signal. Now we can connect that signal to a function so that whenever the signal notifies us, we can run a function. And that's what we want to do. So if we double click on area entered, it will bring up this special connect a signal box here, and we can connect to the grass, and it's going to create a method that is called whenever this signal is emitted. We can press connect like that. Now we can see it's moved us inside of our grass script here, and it's created this function for us. And this function will trigger whenever an area enters this grass area. Okay? And we can put something in here, so we'll just say print grass area entered, just like this. Now, I'm going to take this opportunity to explain a principle of Godot that helps you to write better code and make your project more scalable. It's called signal up, call down. So in this case, our area has a signal, and it wants to talk to the grass node. Okay? We can signal up the tree, and by up, I mean to the parents or grandparents, right? This Area2D is a child of grass, and so instead of trying to call a function on grass, we're actually signaling up to grass, and then grass just calls its own function when it gets that signal. Conversely, inside of our player right here, we're actually calling down. And so let's look at a position here where we're actually calling down. Travel, playback.travel, for example, is one situation, or AnimationTree set. This is a better example here. So AnimationTree is a child. So if we want to do something, if we want our player to talk to the AnimationTree, we can just have it get access to it and call a function. So call down, so anything that's a child or grandchild that this player wants to have access to, it can just call functions on those children or grandchildren and then signal up. Now let's show it in action. In order to get some sort of an overlap here, we're going to add an area to our player as well. So I'm just going to add an Area2D, and I'm going to add a collision shape to it, just like this. And we'll just do a circle. That should be fine. And we can run the game now. If our player, okay, so we're getting a bunch of grass entered, and then if we walk over the grass, we get more. So why are we getting grass entered in the first place? Well, it's because technically the grass in our world is touching. So all of these bits of grass are touching each other, and so their areas are overlapping and triggering the signal on each other. And we're getting this right here printed. In fact, if we were to come into our grass, we want our grass to be destroyed when the area overlaps. We could call you free. This is the function for destroying a node. Then when we run the game, all of our grass will be immediately destroyed because it's all overlapping. So there's a couple things we can do to solve this problem. For now, what we're going to do is just turn off this grid snap and just bring in the collision shape by 1 pixel on each side. So now it's not going to touch anymore in the world, and it won't destroy unless our player walks over it. Now we're able to destroy this grass. And that is because our grass is connected to this on Area2D area entered signal. And whenever this signal is emitted, it calls this function. and we call queueFree. Now, another thing to watch for is this little green thing here. This means that the signal has been connected via the editor, because I showed you how to connect it via the editor. But I'm actually going to show you how to connect it via code, because I personally recommend you connect your signals via code rather than via the editor. And Godot 4 makes it really easy to connect them in code, and so I'm going to show you how. But the reason is because sometimes stuff can get disconnected in the editor. So like if I come in here, somehow it gets accidentally disconnected. When I come back here into our code, if I save, this is no longer connected. And actually, I think if we go to a different script and come back, it's still showing, there, it finally updated. It removed that little green thing, but the function is still here. So you might be confused if your game isn't actually doing what you expect because your signal actually isn't connected. So I'm going to show you how to connect it in code. First, we have to get access to our Area2D. So I'm going to drag this over, hold Control, and drop it. And then we can say Area2D dot area entered dot connect. And then it wants us to tell it what function, or callable, that's just another word for function, to connect this signal to. So we're going to connect to on Area2D entered, like this. We'll just click, do Control C, Control V, and now we've connected it in code rather than in the editor. So whenever this signal is emitted, it will call this function. Now, I kind of glossed over this argument right here, but it's important to realize that when you connect to a signal, the function that connects to that signal has to have the same arguments as the signal itself. So if we look at the area entered signal right here, it has an area argument that gets emitted out whenever the signal fires. And so our function also has to have that. And so that's why our function has one right here. And I'm actually going to call this I'm going to call this other Area2D, just to be clear that this variable right here stores a reference to the area that is overlapping our area. So this right here is the area on our grass, and this is the other area that is overlapping the grass's area. Okay, cool. So we've connected up this signal and our grass can be destroyed, but it's still not being destroyed with the sword. It's just being destroyed with an area that is always on the player. So I'm going to show you how to attach, and we can remove this print here. I'm going to show you how to attach a area on the sword that works similar to a hitbox. And so what we'll do is we'll come down here on our player, and instead of doing a collision shape right here, we're going to delete that. We're going to add a collision polygon. Okay, collision polygon. And then we're going to open up our animation player. And we're going to go into attack down. And we'll zoom in a bit here. And make sure snap is on. There we go. Now we can use this collision polygon. When we click on the collision polygon and come into the inspector, we can actually create keyframes for our attack. And we're going to have to go into the animation tree and click animation. I always forget that. Come to attack down. Okay, and now we click on our collision polygon, and we can add collision points for our sword here. I'm going to go here, here, and here, all like this, and just draw those points. And you want it to complete this like this, and we can then key that polygon over here. Okay? Eat it, and then we can come to the next frame of our attack. We've got new points here, but we're just going to click the plus again, and we're going to create new points for where the sword is now. And this doesn't have to line up perfectly, so don't get too worried about making all of these collision. Oops, I missed that one. There we go. I can right click to delete that. And once you've set them up, you can actually move them around a bit if you want to adjust them. But this doesn't have to be perfect. It can be close enough and still work quite well. So we'll key that. Now we'll come to this next one and repeat the process. Here we go. Again, doesn't have to be exact. Just get it close. Good. We'll key that. Then we'll come to this last one and we'll add just a few here as well. And key that. Okay, so we've keyed all of them. And then at the end of our animation, we're going to open it up and key it very blank. So I just reset it so there are no polygons set up and then keyed an empty one. We can also do that in our reset track. We can come in here and we can actually delete this and then just make it empty and key that. So the reset track will have an empty one as well. Now, I'm only going to set it up on this for testing, but what I'm going to do here is I'm going to turn off snap. And now you can see if we move through this animation slowly, you can see that the hitbox is doing weird stuff. And that's because Godot is actually interpolating the points in our hitbox and trying to animate these points with automatic interpolation. But our animation is just like individual keyframes from a sprite, so we don't want it to do that. And the way we can turn this off is down here in our animation right here. You can see there are properties for for the update mode, how it is updated. By default, with a collision polygon, it's set to continuous, but we want it to be discrete. You can see that sprite frames are set to discrete by default. But once we have that set up, then if we go through this slowly, you can see that it's updating the polygon with the frames to match the frames specifically, which is exactly what we want it to do. And now if we go into debug, we can actually turn on visible collision shapes. And this is a useful tool when you want to see stuff. So we can see there's the animation. It only works for down, but if we come onto the grass and then we swipe, wait a minute, why isn't it working? We can see our collision shape there. Should be working, right? Well, let me show you what's going on here. So when you use an animation tree, it overrides some properties on the animation player. That's why we always have to click the animation tree and click animation. We can't click the animation player and click animation because the animation tree is controlling it. Also, if we were to update the speed scale right here on our animation player, which just affects the speed of the animation, it wouldn't work because the animation tree is overriding certain properties. If we wanted to add a different speed to our game for the animations, we'd actually have to add a new node here, and we'd have to do a time scale node, and then we'd have to connect that in here like this. And if we do a time scale node, then we could affect the time scale through the animation tree because we can no longer do it in the animation player. Well, if you look at the animation player and you come to the callback mode, by default, it is set to this recessive callback mode. If you come to the animation tree and you look at the callback mode, you can see that by default, it's set to force continuous on the animation tree. And I don't want to get into the exact reasons for why you might use one of these over another one or exactly what they do. You can read the documentation about it. It's outside the scope of this series right here. But essentially, we want this to match what it is in our animation tree or in our animation player. So we want to switch it to recessive. And then we should be able to attack the grass now with our sword. There we go. You can see that is working. I'm getting the animation mixer annoying kind of errors that I usually get. So what we're going to do is we're going to pause this video. I'm going to have you pause this video. And I'm going to have you go into your animation. I'm going to have you set the attack. You're going to animate the attack hitbox for all of attack left, attack right, and attack up on this Area2D. And I'm going to pause the video and I'm going to do it, and then we'll come back and compare notes. I'm also going to reload my project to get rid of that annoying warning thing that keeps coming up. So I'll see you in just a second. Okay, I'm back. We have attack down, which you already set up with me, and then we have attack left. Make sure that you have an empty collision polygon on the last frame. Make sure you set it update mode to discrete on all of these. Do attack right, you can put that here, and attack down, or attack up. Here we go, and they're not perfectly set, but they all are set to discrete, and they all are empty on the very last frame. Now if we come back, we can easily destroy our grass from any angle, which is pretty cool. Now that the grass is set up where we can destroy it with our sword, let's create an effect for when the grass is destroyed so it doesn't just vanish. First, come into the project and turn off visible collision shapes. Next, come to the plus button here, and we're going to do other node, and we'll do animated sprite 2D. So the animated sprite 2D is a great node for simple effects because you can make animations with a collection of sprites, a collection of textures, frames, without having to use an animation player. I don't recommend it for more complex stuff. In fact, in the game that I'm working on right now, Wazard, I actually had a situation where I had started off using animated sprite for a lot of the enemies, and then later I had to switch it to an animation player because I needed some of the functionality that exists in an animation player. Animation players allow you to animate any property inside of the game, and specifically very useful ones are hitboxes and hurtboxes. Being able to animate those is extremely useful. And an animated sprite can't do that. I could try and sync, like create an animation player and have an animated sprite and sync animations between them, but that's a huge pain. Most complex things, you just want to start off with an animation player. But for effects, animation sprite is great. Once we have this, we can create a new animation over here. It has this thing called sprite frames. So we're going to do new sprite frames and then click on that. That will open up this new tab down here. We have an animation here. We have the frames here, but there are no frames included in this. So let's press this little add frames right here. We can go into effects and select grass effect, open, and we have to tell Godot how many frames are in this, both vertically and horizontally. Vertically, there's only one. Horizontally, there's 1, 2, 3, 4, 5 frames. So we have to set this to 5. And now we can see those, and then we can click and drag in order to select them all in sequence. Press add 5 frames. Now we have this default animation that just plays. We can actually play it like this. And it's pretty slow. So we could set this to 10. Is the rate that it plays at, and we want to turn off looping. We don't want it to loop. And there we go. Now we have this basic animated sprite, and we can call this grass effect. And save it inside of effects. Now that we have this animation, we'll want it to automatically play when it gets created. And to do that, there's this little icon right here where we can select auto play on load. That will automatically play it. The other thing we want it to do is we want it to destroy itself once the animation is finished, once it's completed. We come to node, we can go to signals, and we can see that we have this animation finished signal right here. We can double click on that and we can connect that to our grass. But it's getting mad at us because we don't have a script. Now we could hook this up in the script, and I know that I just told you that I usually recommend connecting to these signals inside of code. But in this case, if we want to connect to it inside of code, we have to add a script to the grass effect, and it kind of clutters our file system to have a bunch of scripts for every single effect. So what we can do instead is we can actually click Advanced like this, and it allows us to connect to any signal or any function we want. And so we're just going to connect to the queue_free function like that. And don't worry about this information over here. That's if you need to remove arguments and stuff. We can just press connect. It says method name must be a valid identifier. It might be mad at me for having the parentheses. Yeah, it was. Okay. Now we can see that on animation finished, it will queue free. We should be able to test this by coming into our world and finding our effect and dragging in. Oh, it didn't. Oh, I guess I saved the grass. Where did I save the grass effect? I must have saved it. I want to save it in effect. So I'm going to drag it up there and drop it. Okay. We'll put this right here, and then we can just run the game, see if our grass, yep, it animates and then destroys itself. So without creating a single script and writing any code, we've set up a simple little effect using this animated sprite and using signals to connect to the queue_free function. Now we want to create this whenever our grass is destroyed. So let's come into our grass here and go into the script. And this is where you're going to learn how to dynamically, which just means while the game is running, instance or create a node or a scene inside of the game. So up to this point, whenever we want to add something to our game, we've done just that. We've come over here and we've grabbed it from the file system and dropped it inside of the game, right? And that is how you can instance or create instances of our different scenes inside of our game before the game is run. But how do we create one while the game is running? Well, it's not too hard. First thing we need to do is we need to get access to the scene that we want to create. And so in our grass here up at the top, we can say const, we can make this a constant, grass_effect equals, and then we can go preload and then type it grass effect and then select grass effect.tscn because we want the scene file. So this gives us access to this scene file right here. In the same way that we can grab it in our file system and drop it into our world, we can get access to it in code right here. Now we want to actually instance it. So we can come down here into where we queue_free and we can say var grass effect instance equals grass effect.instantiate. Okay, and that's the function for taking our scene file, which is a resource, and instantiating it as a node. Okay, so it's the difference between this file right here and this node up here, one of these nodes that's inside of the game. Okay, that's the difference. So this is the file in the file system, this grass effect. This grass effect instance is the node. Now we've created the node, but we haven't actually added it to the world yet. And so it's just kind of existing in the void. So in order to add it to the world, we can do get tree.currentScene, which just gets the root scene. In this case, it's going to be world. Dot add child grass effect instance. So that adds a grass effect to as a child of our current scene, which will be world in this case, but could be a different level or right, could be whatever. We're just going to grab the current scene, whatever the current scene is, and add the grass. And you can see this actually already works. If you come up here to the top left, kill one of these. You can see it's working, but it's creating it at position 0, 0. And so we want to make sure that we move this node to the correct location because it's just creating it at the default at the origin. Then we can say grass effect instance dot global position equals global position. That just sets the global position of the grass effect to the global position of the grass that is being destroyed, this specific grass. Let's see if that solves our problem. Yep, there we go. Looking good. And now we can destroy grass in the game, which is pretty cool. Now I want to show you, while the game is running, if you come over here into Godot and you click the Remote tab, you can actually see all of the nodes and their properties while the game is running. This is a very powerful tool for debugging. And so we can see, okay, here's one of our trees right here. If we come into the inspector, in fact, if we select all of our bushes and trees right here, it won't let us select them all. Let's just select the player. If we select the player, we come down to their properties. We can find their visible property. We can uncheck it. Now, if we come back into the game, the player is actually invisible, which is pretty cool that you can just manipulate these properties over here in the Remote tab and see them over here inside of the game. That can be useful sometimes for debugging. So we know that our effects are correctly destroying themselves if we watch in the Remote tab. So we can run the game again, and we can come to the Remote tab. We can see all this grass, and while we're running the game, we attack the stuff there. We can see the grass effect is created, and then it's immediately removed. So we can see it adding them to the game's scene tree in real time over here, and see them being removed. If you see nodes being added that never get removed and they're supposed to be removed, you have a memory leak. And so you can watch here for that information. Thank you so much for watching this episode. I hope you enjoyed it and learned something. If you did, please subscribe to the channel. Hit the bell for notifications. If you have any questions, leave them down below in the comment section. If you'd like to support my work, consider donating via PayPal or purchasing my Godot courses. Thank you so much, and I'll see you all in the next video.